Hi everyone, this is the final video of equations and inequalities, and we are going to be looking at inequalities and shading regions. So if we look at an example, you may recognise this from GCSE. I've got to draw these inequalities on the axes provided, and then for the purpose of the examples I'm going to be shading the region which satisfies the inequalities. So if we look at x is greater than -1, I'm going to be using the knowledge of this line is x is equal to -1. And I've got to think about the sign. So I've got a greater than sign, and because it's greater than, the function is not included in the region, and so I need to use a dotted line. I'm going to label it, and then let's have a look at y is less than or equal to 2. So we've got the y is equal to 2 line here, and I've got a less than or equal to sign, so this time I'm actually going to have a solid line. And labeling this one. Now let's have a think about the region. I need any x value that's greater than -1, so these values right here, and any y value that is equal to 2 or less than that, so that can be these here. So this is the region that will satisfy both inequalities. Let's have a look at this one. I've got y is less than x. I know the y is equal to x line goes through the origin, and we've got gradient 1. I've got a less than sign, so I need a dotted line. And now we just need to find the region. I'm not labeling the line because I'm only dealing with one inequality. So if we think about, we could find a point, because sometimes the regions aren't as straightforward to find. You may have already found it, that's great. I'm going to show the point example. So I've got x is equal to -1 and y is equal to 1. So -1 is greater than 1 when I sub it in. Well, that is not the case. So I'm not in the right region. The region must be over here. So I'm going to shade this region here, which satisfies the inequality y is less than x. I'll move on to the next one. I've got y is greater than or equal to 2x. I'm going to have a solid line, and this line is going to go for the origin, but it's got a gradient 2. So I'll start from the origin, and it's going to be something like that. And something like that. Again, I'm not labeling it this time, but I've got to find which side is the region. So I'm going to choose this point again. So x is equal to -1, so I'm going to have -2, and y is equal to 1. So 1 is greater than or equal to -2, which is correct. So I've got the right side. I'm going to now just shade in the region, like so. Let's have a look at this one. Now it's not in the correct form. We would want it in the y is equal to mx plus c form, so I'm just going to rearrange so I have it in the right form. So I've got the y-intercept is 4 and the gradient is minus 1. So I'm going to have a line cutting through those points. It's a greater than or equal to sign, so it's going to be a solid line. And let's find the region. So I might choose the point 0, 0 over here, really easy point. So if x is 0, I'll have 4. Y is, which is 0, so 0 is greater than or equal to 4, which is not the case. So I've got the wrong side. And I'm going to have this region here shaded. I'm going to go to this next example. So first of all, I'll rearrange the top inequality. So I'll have y is less than or equal to 4 minus 2x. And this one we've already seen before, so I'm actually going to start with this one. Y is greater than or equal to 2x. Now I'm going to have a solid line. And I'll label that. Then let's have a look at the other line. It cuts through 4 and I've got a gradient of minus 2. It's going to be something like that. And I can just extend it on a little bit up here as well. It looks like it's already labelled, but for the purpose of this example, you normally label it with the original inequality, so I'll label it down here. Now let's find the region. So this may be the region, this may be the region, this may be the region, or this may be the region. I'm going to start with this point of minus 1, 1 again, and I've got to substitute it in to both really to make sure it works. So for this one I've got minus 2, so 1 is greater than or equal to minus 2, which yes, it does work. And then for this one up here, because you want it on this side, let's try it. I'm going to have 2 multiplied by minus 1, which is minus 2. Then I've got another minus, it's going to be positive 2. So 4 add 6. Sorry, 4 add 2 is 6. And then I've got a 1 here. So 1 is less than or equal to 6, which is right. So it looks like I'm going to be in this region here. Let's move on to another example. This time we're working backwards. So I have the lines, I've got to find the inequalities. So I'm going to start with the red line because this is the easiest one. On the line y is equal to 1. Now I've got a dotted line, so I'm going to have a greater than or less than sign. And if we think about where the region is, y has to be greater than 1. Let's move on to the purple dotted line now. So I've got a y-intercept of 1 and a gradient of 2. So I'm going to have y, I don't know the sign yet, 2x plus 1. The sign is either going to be greater than or less than again, but I've just got to work it out. So I might pick a point. I might pick a point of 1 and 1.5 here. I don't want to choose any points on the lines because for 1, these dotted lines, the points aren't included on the lines. And if I chose the point on this line, well, it could either be this side or this side. So if x is equal to 1, I'm going to have 2 plus 1, which is 3. And 3 is definitely greater than 1.5. So I'm going to write that side. So y is less than 2x plus 1. Now let's move on to the solid line. I've got 3 as the intercept. It's got a gradient of -1. So I'm going to write y. And then you can have minus x plus 3 or 3 minus x. But think about the sign. It's going to be greater than and equal to or less than and equal to. Well, again, if I try this point, 1 and 1.5, x is 1, so 3 minus 1 is 2, and y is 1.5. Well, 2 is definitely greater than 1.5, and I need the equal to sign because it's a solid line. So, what happens if we are looking at quadratic inequalities? Well, we can use shading on graphs to identify regions that satisfy quadratic inequalities. So f is less than f of x represents the points on the coordinate grid below the curve. So any points below this curve. Y is greater than f of x represents the points on the coordinate grid above the curve, so anything above here. Now we would use the same process, so a dotted line represents a greater than or a less than sign, and a solid line represents a greater than or equal to or a less than or equal to sign. So let's have a look at an example then. I've got y is greater than or equal to x minus 2 squared and y is less than 3. Let's start with this one first. I'm going to have a dotted line and it's going to be where y is equal to 3. So I'm going to label it like so. Now let's go to the quadratic. Up here, you can think about finding the roots to be able to sketch this quadratic. The roots are when y is equal to 0, so you've almost got 0 is equal to x minus 2 squared. And we've got a repeated root here where x is equal to 2. So the quadratic is just going to touch at 2 and not cut through 2. And then if we were to expand this out, I would have x squared minus 4x plus 4. So the 4 is going to be the y-intercept. And I'm going to have a solid line. And let's try and sketch this. That's probably as good as I'm going to get on the notebook, I'm afraid. You may be able to get a much neater sketch than that. Just going to label that as y is greater than or equal to x minus 2 squared. Now let's think about the region. Well, using the notes from before, we've got a greater than or equal to sign. A greater than represents the points above the curve, so we can always think about that. So we're going to be looking at this part here, and then we want y is less than 3, so it's going to be below this line. So I'm going to be using this as the region. By all means, if you don't understand that part, you can still rely on finding the point and seeing if it works when you substitute it into the inequality. Let's have a look at the next one. I've got 3 inequalities. So I'll rearrange the first one. So it's going to be 2y is less than or equal to 6 minus x. And then I'm going to divide by 2. So y is less than or equal to 3 minus a half x. This one I'm going to rearrange to y is greater than 1 minus x. And for the bottom one here, I don't need to rearrange, it's already there, but I do need to work with this expression. You may recognise this, it's a difference of 2 squares, so I'm going to have 2 plus x and then 2 minus x. So I'm going to actually work with this one first. Now if I were to expand that out, I'd get back here, and therefore the y-intercept is 4. It's a negative x squared, so I'm going to have this shape, parabola. It's going to cut through minus 2 and 2, and I'm going to have a dotted line. So I'll have something like that. That was not great at all. Let me try that one more time. So that is going to be my quadratic. So I'll just label that as y is less than 4 minus x squared. And then let's move on to the second one. So I've got y is greater than 1 minus x. So I'm going to have a dotted line again. And the intercept is going to be 1, and I'm going to have a negative gradient, and the gradient of minus 1. So it's going to be going in this motion here. Let's label that. And finally, the one at the top here, I'm going to have a solid line, and I've got the intercept being 3, and then I've actually got a gradient of minus a half. So it's going to be going from these 2 points like so. It's going to be going like 1 down, 2 along, 1 down, 2 along, 1 down, 2 along, if you like. And let's label that as x plus 2y is less than or equal to 6. So now I've got to work out the region. Using the notes, just be careful, the parabola is now upside down. So we would actually be looking at any points enclosed by the quadratic. But we've got 2 lines here to think about. Now, regions are normally enclosed by all 3 lines. So I'm going to do a wild guess here and actually choose, say, this point here, 1, 1. And I'm going to substitute it into each of the inequalities to make sure that it satisfies all 3, and then I know that this is the region. If it doesn't satisfy all 3, then I need to pick another point from a different region. So let's start with the top one. I'm going to have x being 1, so 3 minus a half is 2.5, and y is 1. So 1 is definitely less than or equal to 2.5. So that one's right. Let's move on to this one. Now x is 1, so I'll have a 0 here, and then y is 1, so 1 is greater than 0, which is correct. Let's move to this one. I'm actually going to the original. So x is 1, so 1 squared is 1, 4 minus 1 is 3, and 3 is definitely greater than 1. So I've found that it satisfies all inequalities, and I have found the region, which is this here. I'm going to go on to a final example now. So 3y is greater than or equal to 2x, and y is less than x squared minus x minus 2. First of all, while I've just said that, let's work with the quadratic. So I could rewrite this part of the quadratic by factorising. So I'll have x minus 2 and x plus 1. So if we were to go and think about sketching this, when y is 0, I'm going to have x is equal to 2 and x is equal to minus 1. The y-intercept is going to be minus 2, and I'm going to have a dotted line. Something like that. Hopefully yours doesn't have as many wiggles. And let's label this as y is less than x squared minus x minus 2. And I'm going to move to the top part now. So I'm going to rearrange by dividing by 3. And I'm going to write that as at the front. So 2/3 of x. Now I'm going to have a solid line. I need to think about this though. It's going to go through the origin, and I'm going to have a gradient of 2/3. So it's going to go across 3 and up 2. Across 3 and up 2. Down here, across 3 and up 2. Across 3 and up 2. So let me join those points. And I'll label and let's think about the region. Well, I can think about this and go back to the notes if we need. Y is less than this function. So when y is less than the function, it is representing the points on the coordinate grid below the curve. Or it could be anything around here, remember. So I'm actually not including the shaded yellow bit. So it's going to be anything around here. And then I've got to probably think about this line now. So whether the region is going to be above this line, so here and here, or below this line, so it's going to be all of this. So I'm going to choose, let me think. I will try and choose a nice point. I'm going to choose 4, 4 up here. So using this one, we can do. I'm going to have x as 4. So 4 multiplied by 2/3 is going to be 8/3, which is roughly 2.7. and y is definitely greater than or equal to 2.7. So that seems to work. Let's try it in here. I'll go to the top part. So we'll have 4 squared, which is 16, minus 4, minus 2, which is going to be 10, and 10 is definitely greater than 4. So that's worked over here. So it seems to be that it's going to be this region and this region, and not this region. But let's just double check. So I'll try and pick another point. I will pick minus 3 and 1. So up here, I'm going to have x is equal to minus 3. So 2 multiplied by minus 3 is minus 6. Minus 6 divided by 3 is minus 2. And 1 is definitely greater than or equal to minus 2. So that works. And then for this one, I've got minus 3 squared, which is 9. Minus minus 3, which is plus 3. And then a minus 2, which is 10. And 10 is definitely greater than 1. So I've got 2 regions here. I've got this part and this part. Okay, I've done plenty of examples there, so I'd like you to have a go and practice exercise 3G, page 55. This will be the end of the chapter.